Hi guys, so you've had some success with systems of equations, even inequalities already, and you've used substitution a little bit, so you have a little experience solving things by substitution. So now we can put all that to good use here and start figuring some things out. So here's an example of how to set up one-word problem. The Math Club and Science Club bought supplies for a retirement home. The Math Club bought 6 cases of juice and 1 case of bottled water for $135. And then the Science Club bought 4 cases of juice and 2 cases of bottled water for $110. We can use those 2 different scenarios to set up 2 different equations. So here's what the Math Club would look like. If I use J to stand for juice, cases of juice, and W to stand for cases of water, always tell yourself what your variables stand for. That helps. Then the Math Club would look like this. They bought 6 cases of juice and 1 case of bottled water, and that equaled $135. The Science Club, they bought 4 cases of juice. That other one doesn't look very much like a J. I better fix it. J. They bought 4 cases of juice and 2 cases of bottled water, and their bill was only $110. So now you can see 2 equations just like you've had for doing substitution, and we'll use substitution to solve this. So from here on out, there's nothing new. The word problems, the whole gist is just setting these 2 guys up to begin with. So let's see, I need to solve for one variable. So I think I'm going to get this one by itself. It looks the easiest to me. So if I get that W by itself, I would have to minus 6J from both sides. So if I had 6J plus 1W equals 135, and I want to get W alone, I could minus 6J, and I would have W, 1W or W, same thing, is negative 6J plus 135. Then I can plug that in. As you know from substitution, if I know that this stuff right here is equal to W, then in the other equation, wherever I see a W, I can plug that stuff in. So this is the same as a W, so I could put it in right here instead of W. I'm going to make a substitution right there since they're equal. So that would look like 4J plus 2, but instead of W, I'm putting in the things equal to W. So negative 6J plus 135, that would be the replacement, the substitution for W, equals 110. So I use this entire equation, I just replaced the W with the stuff that equaled the W. So then we'll just solve it like usual. So we'd get 4J minus 12J plus 270 equals 110. And then 4J minus 12J would be negative 8J, and plus 270 equals 110. And then I subtract 270 from both sides, and I'll get negative 8J equals negative 160. And then when I divide by negative 8, I'll get J equals 20. So I know a case of juice is $20. That's one of the things they wanted to know. Oh, that is what they wanted to know. How much does a case of juice cost? And then, oh, here's the other part. How much for a case of water? So to find the other part, like you know from substitution, you go back to this part where you found out when you solve for the variable right here. And now that we know that J is 20, I can replace that J with a 20. So the water is negative 6 times 20 plus 135. So the water is negative 120 plus 135. So water is going to be $15 a case. Case of water would be $15. And of course, you can check your work. Make sure that these two things make these little stories true. And then you'll know you have it right. So that's about it. Go see what you can do.